Alright, good morning. So welcome back to, I guess we're in week 7 now. This is like going really quickly, which is probably good. Alright, hope everybody had a good weekend. I played lots of high-low this weekend, which is always entertaining. Saw a lot of really good code on homework 6, and everybody's code noticed when I cheated, which was really awesome. So yeah, we'll talk about homework 6 in detail in a little bit. I want to start by talking about the current one-day program, which is 414, and then go on and talk about the programming assignment that you just turned in. Take a look at some sample code, look at GDB, and using that to find problems in homework 6. Talk about the algorithm in general, and then we're going to move on probably tomorrow to talk more about Unix, some Unix utilities, some more shell scripting aspects, and so on and so forth. So any questions up front before we jump into all of that? All right, well, let's start with ODP 414. So 414 is another string processing function. You're writing a function called mix. And mix takes 3 arguments, which I'm calling A, B, and out. A and B are inputs to your mix function. Out is the result. It's the output string. And you can assume that when mix is called, A and B are not just character pointers, but they actually point to legitimate strings. So arrays of characters in memory followed by a null terminator. Okay, so if you're writing your own test code, you have to set those up before you call mix. When you link with a test bed, A and B have been set up for you, and they point to valid strings. And out should be a pointer to an output area, right? Also an array of characters, a string, that's going to be overwritten by whatever output your mix function produces. And the whole behavior of mix is to just interleave those 2 strings. And so if we think of those inputs as A and B, the output string will consist of the following characters in this order. First character of A, first character of B, second character of A, second character of B, third character of A, third character of B, and so on, followed by a null terminator. Alright, so it's mixing the 2 strings together. Simplifying assumption, assume A and B have the same length. Could be 0, could be bigger than 0. Empty strings are valid. But they won't be null. Okay, they'll always point to some string in memory. But they could have length 0, they could have length 1, they could have length 15. But they'll have the same length. Which means your output string, your output string will be twice the length of your input. Where by length I mean the number of characters, not counting the null terminator. And I don't care what value the function returns. You can just return 0 or 1 or whatever. We don't do anything with it. Why does it return on the end? Probably just habit. Alright, so basic behavior. Right? Let's say we're mixing ABC and XYZ, and out is the name of our output array. Out will be the string A, X, B, Y, C, Z, followed as usual by a null terminator. Alright, so it's just an interleave function. You want to test this thoroughly. I have several test cases running in the assess system, and I will test empty strings, strings of length 1, strings with, lengths longer than 1, strings with weird characters in them, strings with new line in the middle of them, any legal string, okay? Remember, a string can have new lines in the middle. That's totally legal. The string is terminated by the null terminator, the \0. Any other character, totally fair game. So don't look for new lines or spaces and do anything special with them. Just treat everything as normal. I gotta turn off my noise because everyone's hopping in. Alright, that's enough of that. Okay, good. All right, so that's how it interleaves. And you want to test this, right? Make your mix function tested with your own test bed. Don't just run it through assess, because unless you get this code perfectly right, what you're going to get is 0 out of 10 on some tests, 10 out of 10 on other tests, and you don't know what the tests are. That's deliberate, right? I want you to figure out your own test cases, do your own QA on this. So try it with empty strings, try it with strings of length 1, try it with longer strings, try it with things in different orders, right? Sometimes calling your function once will work great, but if you were to call it a second time, maybe with a shorter string, you discover that you're not terminating your output string correctly. So you got to call this, 10, 15 times with different arguments in different orders. So how do you drive this thing? Well, make an output array. Make it big enough to hold whatever size strings you're planning to test with times 2, and then just call mix. And since we're not modifying, well, you're probably not modifying these strings, you're hopefully not modifying them, we can pass these as just, strings inside quotes. Right? So call mix, passes the 2 strings and out, and then just print that out with, a %s. Put it inside angle brackets, so you'll notice, spaces on the end. And then, try some other stuff. Mix A with B. Mix an empty string with an empty string. That should come back with an empty string. If it prints a space in between the angle brackets, you got something wrong, right? Just for fun, try mixing 2 new lines together. You should come up with a string that contains 2 new lines. Try mixing, A new line B with 1, 2, 3. Your result should be A1 new line 2 B3. So experiment. And like I say, don't just run this once, get the output, and say we're done with that test. Call it multiple times in a row, right? In particular, call it with some long strings, and then call it with some shorter strings right after that. That will help you pick up if you're not null terminating correctly. So think about test cases. Think about how you can exercise this. Link up your test bed. If your test bed's called main.c, link it up in the usual way. Once you're sure that it works correctly, go ahead and link up with the official test bed in the usual way, and then assess executable name, source file name. Alright, and I think there's 4 tests, and each test has a series of things that it tries to mix. Alright, so how do we do this? So there's a lot of ways you can mix these strings together. I think the easiest way to code is to do the same thing you did in your prior ODP, which is build an output string character by character. So let's just start with, the prototype that's given in the assignment. You can call these whatever you want, obviously. But here's the basic idea. We want to go through each character of these strings, and we want to just add them to an output string in the proper place. And that's what you were doing when you went through and removed, x's from a string. You built a new output string, and to do that, we needed to know where in that output string we should place our characters. So I'm going to, bring back my output location variable, and I'm going to loop through like this. And I can use string length A, I can use string length B either way because they have the same length, right? We've been told that. And I'm not going to go less than or equal to. I don't want to deal with a null terminator inside my for loops. I'm going to deal with it outside. All right. I think it's really important when you're writing code that you know exactly what your variables represent. Okay. What is outlook? It's where I'm going to store stuff in my output string. Yeah, that's true, but let's be more specific than that. Because where you're going to store things in your output string, well, is this the location where you're going to store the next thing in your output? Is it the location where you stored the last thing that you put into your output? Is it something different? The answer to any of those questions might be yes or no, but you have to have a really clear idea in your head what you're using this variable for, or any variable. So the way I'm cobbling together the pseudocode, I'm thinking of this as where the next character is going to be stored. Okay, so this is location for next character in my output string. That tells me I should initialize it to 0. Because when I first start, where should my next character get stored? It should get stored at out bracket 0. That's the first character of the string. If I wanted this to be the location where the previous character was stored, I would probably initialize it to -1, which doesn't exist, but there was no previous character stored. This is reminiscent of dealing with stack pointers in Engineering 270. If you didn't like those, don't worry about it. All right, so I'm going to go through every character, every index in my string A, which is also an index in string B. And I'm going to basically take my character from A and copy that to my output string, where output loc says where I should store that character. Well, as soon as I've stored something there, I need to increment my output location. And then I want to take the same indexed character from B and save that in my output string. And anytime I save something at that location, I have to bump up my output location. So this will loop through and it will keep reading character 0, character 1, character 2 and tacking them on side by side in my output string. And then when I'm done, the only thing I have to do is add on my null terminator. And if outloc is always where the next character should be written, then once I get out of my loop, I should just be able to store that at out bracket outloc. And that should complete my mix. All right, so questions about that? This is a good exercise if it's not working the way that you thought it would. It's good exercise for playing around with GDB. Because it's a relatively small loop, and of all the things that can go wrong, right, they're all going to happen basically inside here. And there's lots of little things that can go wrong. You can be iterating too many times or not enough times. You can be putting your null terminator in the wrong spot. You can be incrementing in the wrong place, and so on and so forth. So you can GDB this and get some good practice like that. All right, so let's talk about the homework that I just graded and entered into Canvas. So this was homework 6, which was the high-low game. Um, General comment up front: this was really awesome code that people wrote. Okay, this worked way better than any time I've ever given high-low in the past. Inevitably, most of the issues that students seem to run into are that the game simply doesn't play right. Right? It doesn't guess the number if you're thinking of, say, 100 or 0, or it calls cheating too soon, or it guesses, you know, the same number more than once in a row. The basic underlying algorithm doesn't seem to get implemented correctly. Almost everybody implemented the algorithm perfectly. Okay, so it was doing perfect game mechanics as far as what it was guessing, when it would call cheating, and so on and so forth. Almost everybody's predict function was perfect, and, you know, accurately said maximum number of guesses that would be required. So that was all really good. And the grading was you know, straight from the assignment. I basically said what things I would look for and how many points they would be worth. So if you get a note saying, you know, use this correct algorithm for making each guess -10, it means that there was a problem with that criteria. If you get a note saying, you know, perfect error handling and command line arguments -7, there was a problem with the error handling. So I listed in the comments the things that caused deductions in the grade. All right, let's see. So yeah, I don't need to go through these. We talked about the details of these points when we first talked about the assignment. But I will show you what I did to test the code. Now, hold on, I gotta cheat over here a second. All right. So I downloaded your repository, right, from GitLab, and I have something that, you know, just goes through and it knows each of your Git IDs from the email you sent me week 1. So I run that. I downloaded all of these at a little after 8 o'clock Friday morning, and then push those over to another account on the system that has no privileges and no precious files. And then one by one went into each of your repositories and looked to see what was in there. So I wanted to see a README, a make file, your .c files, your .h file, and nothing else. Okay. And then I eyeballed the README and made sure, you know, that had something reasonable in it. And then I went about making your files. So I would say make, and it should compile all the pieces together and then build the executable. And then I would say make again, and it should say main is up to date. And everybody did a really good job on the make files, by the way. So I would make it again, and it would say that main is up to date. And then I would say make clean, and I would make sure that it removed all those files and left me back with the original setup. And you were not supposed to remove star.o. Okay, that was spelled out in the original assignment. So you needed to remove the particular files that your make file makes. And then I said make again, which built everything. And so now if I say make, it should say it's up to date. And then I touched a file, and touching basically updates the access time. So that acts as if I had edited predict.c. And then I said make again, and it should recompile that one file and then build everything. So that was the exercise of the make file. And then I started exercising the game itself. So the first thing is if you just run the command with no command line arguments, it should play a game between 0 and 100. So I wanted to see a mention of 0 to 100 either here or, you know, somewhere, right, before you're asked to pick a number. And then I used one argument, which means play between 0 and that number. So I made sure it said 0 to 200. And then put in two arguments, and it should play between those two. And then tried making one of those arguments illegal. And then tried adding a third argument, and that should throw an error, and so on and so forth. Okay, so that's checking that you know, it's called main, that's in the make file. Plays correctly with 0, 1, or 2 arguments, perfect error handling the command line arguments. Greets the user in the beginning, tells the user the range of numbers, waits for the user to hit enter after thinking of a number. All right, so then I want to check the number of guesses. So I went from 100 to 106, and that should be 3 guesses at the most. And then I went from 100 to 107, and that should be 4 guesses at the most. And if you got those right, then your predictive algorithm is probably working correctly. And then I started playing the game. So I mostly played between 0 and 100, and thought of a number, so I'll say 50 is low, and I'll say 75 is high. And so now I wanted to check to make sure that you were handling the answer correctly. So if I hit an enter, you should say, you know, enter H, L, or C. If I type something that's not exactly L, that should ask me again. If I type an L with spaces in the beginning, that should ask me again, and so on. So I make sure that it's handling those inputs correctly, and that if I say C, it takes that as correct. And then I would do some guessing. So I said that 75 was low. I said 88 was high, so 86 is low. 87, if I tell it 87 is low, that should call cheat, which it does. So it can detect cheat in the middle range. And then I just drove it to the endpoints, made sure it gave me a chance to guess 0. And if I said that was too high, it would call cheat. And then drove it to the other extreme by saying everything was too low. Make sure it asks me if 100 is my number. And then if I say that that's still too low, then it detects cheating. So that was the basic gameplay. And then went ahead and looked at the source code, looked at the README, eyeballed the make file, and that was pretty much the whole range of testing. So you're welcome to run similar tests yourself if you didn't already. And if you have any questions about, you know, the grading that I did, or about how you could change your code or something like that, come and talk to me. Overall, this was a really, really successful assignment for most people. Okay, minor issues here and there, right? You know, issues with parsing command line arguments, issues with parsing the answer from the user, the H, L, or C, things like that. Those can be tricky. But by and large, most people, you know, were pretty much right there with their code. Now, you know, some people told me that they ran out of time, or that, you know, they misjudged the difficulty, or they couldn't figure out how to get something to work. And in some cases, you know, I got code that just would not compile. And so if you're not sure, right, what was going on with your code, if you weren't able to get it to run the way you wanted it to run, and so on, definitely come by office hours. Okay, we can look at your code together, we can go through it, and we can talk about ways to you know, figure out what's going on and fix it and go from there. All right, so questions on that part of homework 6. All right, so let's look at some sample code. So this would be my repository. I didn't actually put this under Git, but this would be my repository, right? So it's got a README, it's got a makefile, and then it's got my source files, including a .h. So the README, I didn't really get very picky about. I really want to see, your name, the class, the date, and a description of the program. There are a few cases where the README was just like, high-low game. But I didn't put on here that, I would take off points for a weak README, so I didn't take off points for that. But your README is, when someone downloads this, that's often the first thing people will look at. A lot of times people don't want to dig into your C code. They don't want to look at your makefile. They don't want to, try to reverse engineer what you've written. They want to know, what is this thing? How do I use it? What's it all about? What should I be careful about? What should I look out for, right? That's what goes in the README. If you put this in a Git repository, right, when you go to the repo homepage, you'll see the contents of the README file. So this is kind of your front page to the whole project. So this was just, kind of a sample README I put together for my version. So high-low game, CSE224, fall 2020, sample code, there's my name, there's the date. Here's a synopsis. The program asks the user to pick a number. We'll try to guess it. After each guess, says if it was high, low, or correct, program adjusts its guess and re-guesses. All right. So that's kind of a one-paragraph, 2-sentence, 3-sentence synopsis of what this program does. This describes basically what it does. Well, it uses a divide and conquer algorithm, splits the range of possible numbers in half with each guess. If you know algorithms, if you know divide and conquer, if you thought about high-low, this says a lot, right? If you don't, then maybe it doesn't. Also predicts the maximum required number of guesses, which is on the order of log 2 of the range of numbers, right? And I'm not going to put in, a lot of detail in the README that somebody, might go into the code to look at. But, I'll mention, it makes a guess for the number of guesses required, makes a prediction, and it's basically a logarithmic function, right? And if they want to know the details, they can go and they can look at that code. If the range flips at any point, low is bigger than high, then it detects cheating and the game ends. Alright, and then I put in a synopsis of how you can run this code. So you can either say main, or main with a high number, or main, that should be low followed by high. I just got a 0 on my assignment. Alright, you didn't see that. Alright, so main followed by low followed by high, right? And then in all other cases, low has to be non-negative and high has to be bigger than low. Any other usage throws an error message and the program exits. Alright, now I just mentioned how to use the makefile. You can say make clean, you can say make, and the executable is called main. So that's kind of, a one-page synopsis of like the very top level information about this project. It's not a lot of detail, but it's enough for somebody to see what it is, figure out how to build it, figure out how to run it, right? And a few other details like, what happens if you put in an illegal argument, what happens if you try to cheat, and so on and so forth. So that's a README. So the makefile, so I added one embellishment to the makefile, which is I added some variables. Instead of saying GCC everywhere that I wanted to compile, I said $CC. And I put something up here in the beginning which said CC is a variable that's equal to GCC. And anytime that I see $CC, that gets replaced with, in this case, GCC. And GCC is the only C compiler we're using in this course, but sometimes we want to put flags on this. Sometimes, for example, we want to compile with debugging information, and I want to put a -G after my compilation. Now, I can go into my makefile and I can add a -G before all of these -Os and -Cs, but that's error prone. So I have another variable called C flags. These are compile flags. Right now, that's equal to nothing, which means $C flags gets replaced with just an empty space. But if I set C flags equal to something like -G, then every time that GCC is called in here, it'll do GCC -G. And so I can change one thing up here and change the behavior of all of these statements in my, my make file. My make clean, I listed all the files I want to remove. I put a -f on there because -f, that forces the removal. And in particular, if the file doesn't exist, it won't give you an error message. So that's just a nicety nice. And if these files were marked as not writable, but I had permission to change those permission bits, this would override that and just silently delete them. So it's just a somewhat cleaner but potentially more dangerous way to remove files. Alright, so basic makefile, and this is what most people's makefiles look like, right? Main is built with these object modules. Here's the compile line to actually build the executable. And then each object module depends on the .c file, and there's a compile line to build the object. Main also depends on the include file .h, but the way you build the object is just to compile a .c, and the .h is included, so you don't have to compile the .h on your GCC line. So that's kind of a boilerplate makefile, and if you keep a copy of something like this around, it's pretty easy to just modify it for whatever project you're working on. It's somewhat rare that I actually make a makefile from scratch. I usually just grab an old makefile and modify it. Alright, so main.h, not very inspired. It's just function prototype. So it just prototypes those 3 external functions that you were required to produce. GetAnswer.c. So here's what the function looks like, right? Takes no arguments. Reads an answer HL or C from the user who's already been prompted, right? So I want the person using this to know that this will not print out a message like, hey, enter HL or C. I'm assuming that's already been prompted. This is just doing the input part. Okay, and then it returns a single character, which is HL or C. If you put in anything other than HLC, then it will prompt you and get input again. And it continues until there's a valid response. Right? So that's the one paragraph synopsis of this function. And then the getAnswer function, so there's temporary storage. This is going to be an infinite loop, and I mentioned once you get a proper response, we'll just return directly from inside the loop. We use fgets to read a line from the user. I go ahead and remove the new line just because we talked about how to do that in class, so I wanted to do that in my code. And when we're done, what we have is presumably a string that's equal to just quote h, or just quote l, or just quote c. So I use string compare to see if the buffer was exactly quote h, and if it was, I return the character h. If I didn't remove the new line, I could compare it to quote h \n, right? And that's what my input should be if the person just types h and hits enter. If I didn't want to use string compare, I could see if buffer bracket 0 equals single quote h, and buffer bracket 1 equals single quote \0, null terminator. So there's a lot of different ways you can do this, and if it's L or C, I return those. Otherwise, I print a prompt, and then we'll go back to the top of the loop and repeat the process as many times as needed. So some people try to do this with scanning, and scanf is, you know, a very particular function. It will do what it is supposed to do very well, but sometimes it's tricky to know what it's supposed to do. In particular, you know, scanf, it treats spaces specially. Spaces are considered separators. So if I scan with a %c, I will ingest a single character. There's almost no reason to scan a string starting with a %c, because if you want the first character, it's just string bracket 0, right? But if you scan a %c, %s, what's it going to do if there's a new line after the first character? Play around with it and make sure, right? Because a new line will not match into a %s, I believe, but anything else will. But scanf is a really powerhouse function. If you're trying to do things like convert integers or floating point numbers or something like that, go to scanf, right? And I mean scanf whenever I say scanf. But if you're trying to break up a string, scanf may not be the best way to do it. And if your string can contain spaces, don't use scanf, okay? Because it takes spaces as separators. And if you want to know what those separators are, you're going to totally lose them if you scan with a %s and so on. So different ways to do this. Let's see. Oh yeah, so someone said their makefile was creating intro.h.gch files. Make sure you're not compiling a .h file. If I try to compile main.h, I get this main.h.gch file, right? We never really want to compile a .h file. .h files get included inside .c files. And so we don't actually list them on the GCC line. Just like we don't list standard IO.h when we compile a typical C program. All right, so that was get answer. So intros, not very exciting. Doesn't take any arguments, doesn't return anything. It just, you know, prints out a few lines of text to say welcome. And I put that in there just to basically, you know, give you one function that you were going to call from main. Didn't have to pass anything to it, didn't have to get anything back, but it had to be declared in a separate file, intro.c. So it's a kind of warm-up to breaking your code into separate pieces, separate files. Predict.c. So this needs math.h, okay, which is why we need the -lm when we compile to make the executable. And I put a little bit of wordage in here, which wasn't really necessary. Basically, calculate and return the maximum number of guesses, but the number of things you can possibly pick is one more than high minus low. So if you're guessing a number from 1 to 10, there's 10 things that you could be guessing. Right, so it's not 10 minus 1 is 9, it's 10 minus 1 plus 1. Okay, this is a fence post problem. Do you count the ends or not count the ends? So 1 plus high minus low is the number of possible things you can guess. Since we're cutting that set of things in half each time, we want to keep cutting it until we have less than 2 things that we could pick. Okay, that's what log 2 will give you. It's the number of times you can divide something down until it's less than 2. And it could be, you know, 1, it could be 1.9, it could be 1.999. In any of those cases, you need one more guess, which is, you know, once you've got it down to less than 2 options, you know what the right answer is, but you still have to guess it. So the total number is 1 more than the log of 1 plus high minus low. So that's the range, the number of things we're trying to pick. This is the log base 2 of that, and then we add 1 more to it to say how many guesses do we actually need. So that was just the algorithm straight out of the assignment prompt. And then the last piece is the main program. So, you know, some kind of header block with your name, date, description of the program, that kind of stuff. I'm including main.h, goes in double quotes because it's in my current directory, angle brackets, take it from a system directory, user include. And then error is a function defined in here that I use for printing out an error message. So I prototype that up top. Here's our sort of standard declaration of a main program with arguments. Here's the temporary array that I'm going to use to pick up the extra stuff after an integer using our trick that we use to see if someone entered exactly an integer with nothing else after it. And a note here that if you're worried about buffer overruns, right, you could check the length of these arguments and truncate them, right? So if argv bracket 1 is, you know, 1,000,000 characters long and I don't want to, you know, scan that into a 1,000 character array, just throw a null terminator into character 900, right? And I can scan it safely. But we're not worried about buffer overruns because I'd be hacking myself if I tried to do that. All right. So how do we process the arguments? I'm going to keep a pair of variables, low and high. Okay. This is the low and high point of the game that we're playing. So I'm going to ask the user to think of a number between low and high. and I start those off at the default values. And there's two ways those defaults can be overridden. The first way is to specify one argument. And if you do that, that one argument should be a new value for high. So, if argc is 2, the person is presumably specifying a high range. Do our fancy parse, pick up the extra stuff, make sure it returns 1. If it doesn't, there's an error, print out an error message and just return. Right? Otherwise, my value of high has been set to whatever the command line argument said. Okay, that takes care of one argument. If argc is 3, there's 2 arguments. So first I'm going to parse argv1, I'm going to parse argv2. If any of those parses fail, print an error message and return. If both of those succeed and I get out of my 2 if statements, then I know that low and high have been set to, presumably new values. If argc was not 2 and not 3, none of this code executes and low and high are unchanged. If argc was 2, high will be changed, but low will still be 0. Alright, if argc is bigger than 3, too many arguments, print an error message and exit. So these are all my possibilities, right? argc could be 2, could be 3, could be bigger than 3, could be none of those, which means it's 1, which means there were no arguments. And since all of these conditions return, I don't need to nest these inside else's, right? I could, but I like as little nesting as possible. I like well-nested code, but I don't want to nest more than I have to. Because every time I nest, it's another level that I need to keep track of in my head to know where I am in my code. So all of these are, at the first level of nesting directly inside my main program. And so they're all, 2 spaces indented from the left. Alright. If we get down to here, low and high have been successfully set. Now we have to make sure they're legal. So if low is negative, or if high is less than or equal to low, print an error message, exit. Alright, if we get down here, we got good arguments, we're ready to go. So say hello, print out the intro message by calling the intro function. And then ask them to think of a number between, tell them the range of low and high. And let them print enter. So I just used fgets, right? Which will, hang until they hit an enter key. And then make a prediction. So call the predict function that returns an integer, print it out as %d, and say, I'll guess your number in at most %d guesses. And then here's a temporary variable, that's our current guess. Here's the guess number. So my interpretation of this is the number of the guess we are about to make, the next guess. Okay. It's 1 more than the number of guesses I've already made. Now I could have set it to 0 and have it be the number of guesses I've made, right? But you got to have a consistent idea in your head, and as long as you're consistent, right? So done is a loop control, which says when the game is done. And then here's our main loop. So while the game's not done, make a guess, right? Divide the range in half, print out that guess along with the guess number, and increment the guess number after we've printed it out, and ask if it's high, low, or correct. Call getAnswer. When getAnswer returns, we know this answer is either H, L, or C. If it's H, adjust the high part. If it's L, adjust the low part. Otherwise, it must have been C. Set our done flag to say we're done. At this point, we do our cheat detection. If the low range is bigger than the high, call them out, set the done flag to 1 to say the game is done. And this will keep looping until that done flag is 1, and then we can say thanks for playing and exit the program, and the usage message just prints out, a reminder of the different ways you can run this program. All right. In the previous section, I used this as an example of playing with GDB to find a problem in this code, because I deliberately put a mistake in here. if you want to see that, go ahead and look at that from the video from the previous one. But I want to take the last 4 minutes and instead talk about the idea of a divide and conquer algorithm. So this algorithm is an example of a type of algorithm called divide and conquer, which is basically where you take a big problem and you split it into pieces. And you solve one or more of those smaller pieces and use those solutions to get the solution to the original problem. And that's exactly what we're doing here. We're saying, think of a number between 0 and 100, and I'll guess 50, and if you tell me that's low, I now have a totally new problem to solve, which is try to guess a number between 51 and 100. That's a simpler problem. If you said 50 was high, I'm going to say, okay, I'm playing a new game. I'm going to try to guess a number between 0 and 49. And the person's already thought of a number in that range, but now it's a simpler problem, right? So I've coded this up in a very unembellished version of high-low. It doesn't do any of the error checking, it doesn't do any of the prompting and so on. It always plays 0 to 100. But let's say we're thinking of the number, I don't know, 42. We'll say that's high, that's low, that's low, that's high, that's low, that's low, that's correct. Works perfectly. This is the whole program. It's tiny. And it's a classic example of divide and conquer. So I wrote a function called play that plays high-low between two numbers, in this case 0 and 100. And what does play do? Well, it makes one guess in the middle of high-low. It asks the user if that guess is correct, high or low, gets the answer, and then, you know, simplified parsing of the input. If the person said that that guess was too high, I simply play another game, where I'm playing a game where the person's thinking of a number between low and guess -1. And then I'm done. I return. If the person said that guess was too low, I simply play a game where the person's thinking of a number between guess +1 and high. And once that game is finished, I return because I'm done. And if the person didn't say high or low, I simplify an assumption, assume the answer is correct, and I just return. The game is done. And there's no explicit looping in here. There's no while loop or for loop. This is really a direct implementation of this divide and conquer approach. We want to guess a number between 0 and 100. I'm going to guess 50 if they're going to say it's high. Well, the only thing I'm going to do is I'm going to play a game where we guess a number between 0 and 49. And we're done. Okay, so this is recursion. This is a recursive algorithm. And this maps to mathematical induction. If you're in CSE215 right now, we're finishing up induction today. Same thing, right? And we can prove that this works because we know that if high and low are equal to each other, the guess will be, you know, the same as high and low, and that will be correct. Because if you think of a number between 10 and 10, it's got to be 10. So we'll do a lot of this in CSE222. And having a function like a function called play that calls itself, right, but with a smaller problem, that's the hallmark of this divide and conquer approach. And we'll use this next quarter for sorts and searches and all kinds of good stuff. So I just wanted to show that as an example, preview of coming attractions. All right, have a good afternoon. I will see you next time. Come by office hours, 7 to 9 tonight if you want to go over code and such. All right, have a good one. Thanks.